Hello, everybody. Welcome to this first webinar for Ryax Technologies. We're really excited to host all of you for this first webinar, which title is Industrializing Data Science to Track Pollution in Cities. Yiannis will be here today to roll you through all the steps that we actually made to industrialize a workflow in the city of Rennes, in Brittany, in France. Yiannis is CTO for Ryax Technologies. He has a long background in research and industrial applications for computation management of very complex data computing workflows, etc. So he's our tech guy today, and he's gonna explain everything he can about what he did for this specific use case. And I myself, I'm Julian, I'm marketing director for Ryax Technologies, and I will be taking your questions during the session. So I'll let Yiannis start with the role of this presentation, and enjoy your first webinar.
Okay, I hope you can hear me well. So thanks, Julian, for the introduction. And so our first webinar, as Julian said, is going to be on a particular use case, industrializing data science to track pollution in cities. This is the outline that we are going to use for today. So we are going to see a little bit the context of this air quality project. We are going to focus on a specific data science analysis, on the object detection analysis. We are going to see in general what are the data science industrialization challenges that we have, and then we are going to focus more on how we deal with those challenges with Ryax platform, how we can automate data analytics workflows. This is our first part of the demo, and then we are going to go in detail in how we can deploy automations on hybrid edge cloud infrastructures. Okay, so if we see a little bit on a high level, what is this air quality project? Controlling air quality requires a much better understanding of how the pollutants are dispersed in the air. So when we manage to analyze this dispersion with measurements and perform numerical simulations, we can go further into how to into actually understanding and identifying the causes of how this pollution has been produced, and also go even further and make questions such as what if the weather changed, or what if a specific accident was to happen on this specific area where it has already a lot of pollution. So these things can be dealt through numerical simulation and through different collection of measurements around the city. At the same time, we can make those data available to citizens so that they can be aware of what is happening in their city, and also to authorities, which is very important because these are the people that are going to enable decisions and take public actions. Now, in our case, in this specific project, we focus on a specific pollutant, the particulate matter, which is one of the most dangerous. I've included a recent report made by the European Environment Agency, where we can see different analysis on the pollutants that we have around Europe. And the thing about particulate matter is that it is caused by road traffic, residential heating, and also agricultural activities such as fires or stuff like that. So in our case, we focus only on this pollutant, which is, as I said, the most dangerous. Now, let's see a little bit our particular use case, how it is settled. So we have we have the buses that are the public transport in the city of Rennes that go around. They have been equipped with pollution sensors, with GPS, with connection 3G and LoRa, with a camera, and all these type of sensors are controlled through a specific processing unit within the bus. Now, there is a centralized computing environment where we can store all the data collected from the bus, and we have also the depot from where all the buses can go, the terminal of the buses where they go during the night, and we also have a high bandwidth connection which relates the actual terminal with a centralized computing environment. Now, the interesting part here is that we connect this whole environment with HPC or cloud computing resources in order to perform these numerical simulations that I mentioned before. And finally, connecting all this with a centralized visualization tools and providing data, as we mentioned before, in open data, is something that is very important for us in the particular project. Now, a certain case that we also would like to address is emergency situations such as a fire within a factory or a certain accident that can happen in an industrial setting. So having drones that can circulate with the same type of sensors like we have in the bus can help a lot in the way that we are going to collect the results as fast as possible, transfer them to a centralized environment, and then to the cloud or to the HPC center in order to perform the analysis and make the predictions related to, let's say, the specific accident. Now, the whole environment is can be separated in different layers of where the computations take place. We are going to go more into detail into that, and I don't want to go very technical, but there are parts that can be executed at the edge, closer to the sources, closer to where the measurements are taken, parts that are that can be deployed at the fog layer where the centralized, let's say, servers are situated, and finally at the cloud. And all this orchestration between the different computing environments and how the data analytics are executed in this, let's say, whole distributed environment are operated with Ryax. Okay. Now, let's see a little bit more into detail what exactly we measure here, okay? So we mentioned particulate matter. So this is the main pollutant, the environmental sensor that we use. But then we also need to take some other, to track measurements such as temperature, humidity, in general environmental conditions, and also the GPS coordinates of the bus, since the buses are going around the city, so we need to know where exactly they are. Now, this is a graph that we have plotted, you know, through the different measurements that we have taken from one of the buses, and you can see here a certain peak. There are different ones, but there is a particulate that is pretty high. So we were trying to understand what's happening here. Is it what is around the bus? Is there surrounding traffic, or is it something that is actually biasing the sensor readings, or is it a real measure that you know, has to be related with a particular part of the city? So if we go more into detail into how this, you know, this contextualization of the measurements takes place, this is something very important for us, okay? So, because if we have a lot of peaks like that, we need to see what exactly happens around the sensors when we get the measures. So we need to analyze this context and provide accurate insights. So we create video or image analysis software in order to detect the different objects that we have around our sessions, around the buses every time. A certain point that needs a little bit more attention here is that since we collect images from the city where people are going around and cars and motorbikes, etc., we need to protect the privacy of the citizens. Okay, to do that, we need to, if we have to transfer these images for a certain reason, we need to blur the specific images where you know, in order to not have faces or numbers of the cars, etc. Now, this is the main data science that we are going to focus on with the program that we are going to develop here with the actual application. Now, consider at some point, okay, we are data science, we provided, we developed these algorithms. Now, how do we go in production? Okay, this is a real, it can be really problematic. The object detection algorithms that we just saw uses AI algorithms, so machine or deep learning models. To do that, you need processing power to do the training and to do the inference. It may even be heavy processing power because the training part can be much more can need much more processing power than the inference. Another thing is we need automations, okay? Because we cannot expect that we are going to have an operator within the bus and wherever there is a threshold, let's say the threshold of the sensor is higher than normal, is going to trigger the actual execution of the video or the image analysis. So we need the repeatable executions to be either periodic or event triggered. Then another thing is we need to have fault tolerance as much as possible. We need to be able to facilitate the debugging of our programs. We need to monitor and observe in a high level control in order to know what's happening, because we are going to deploy our algorithms in different buses throughout the city. So we need to know what's happening and if everything functions correctly. And finally, we need a way to control the versioning of our programs, of our software, and capture the evolution of our program. Now, all these things are not easy, and I'm going to show you in a demo how we are going to go more, how we do these things with Ryax. So first of all, we are going to go into first part of the demo, which is automating data analytics workflows. And then we are going to go on a second part, which is deploying them in an actual complex infrastructure. Okay, so concerning the first part, this is what we are going to do. I'm going to do a live demo of Ryax. We are going to introduce some concepts that we use. We are going to create a workflow for the automation of data analytics. This is the actual object detection part that I mentioned. We are going to create functions, which are the parts of the workflow that are actually making the data transformations. I'm going to go into detail in that. We are going to deploy a workflow and trigger executions of data analytics and see, you know, what are the results. And during that time, we are going to monitor resources and observe our executions. Finally, we are going to evolve this first workflow that we created related to object detection by creating a new variation related to the blurring, to the data privacy part of the program that I mentioned before. Okay, so I'll hope that we are going to You see, I hope that you see what I'm sharing here. Perfect. Okay. Okay, so we are data scientists. Usually, as data scientists, we use a certain interactive computing environment, let's say, to make our programs. So this is the object detection program where I use TensorFlow with a mobile net model. So you can see the different parts. You download the data, you load the data with the model. You find the different files. So we are going to enter images in a certain directory. And then we are going to run the model. So the actual inference, we are not going to deal with the training now. The program here is just to run the prediction. And then we have a certain, let's say, function that is going to call the different parts. So the important here to remember is that we have the model, the images, and also which is going to be the input where we enter the different images that we have, and then the output where we are going to receive the tagged images where the objects have been detected. Okay, so this, let's say, functions correctly. I'm not going to show you now for the sake of simplicity. And now it's the time that we want to put this program into industrialization. Okay, so this is Ryax. We are going to connect to Ryax platform, the web interface. There is also a command line interface, but here we are going to see the web interface part. So it's a multi-user environment. I enter, this is our landing page. So you can see different workflows already here. Let's go directly on a certain functionality. We are going to create a workflow here. Let's name it like this. Okay, so our workflow is created successfully, and we land on the page where we can actually edit our workflow. Now here we have a choice of functions. I'm going to go into detail in that, but before that, let me create a new function to actually express what I showed you before, which is the detection software. So here we have different choices of languages to choose. We can go through a container, or we can go for a Python. Other programming languages are also supported. In our case, we'll go fast. We'll go for a Python function. Okay, so let's go here, create our function. Let's give it a type, a name, human name, in order to understand. We can have different details, logos, etc. The important thing here is to add the inputs and the outputs that I mentioned before. Okay, so here you remember I mentioned the model. Okay, model name. You have a model name to insert, and then here you have a string or a enum if you can have multiple ones. Another input here, as I mentioned before, is the images. So this is the images to be tagged. Okay, and then here, yeah, we'll have the help. If you are not doing a demo, you can have the time to. You can take your time and fill it up correctly. But now we'll go a little bit faster. So here we have the tagged images. Tagged images directory. And then the help, etc. for images. Okay, again, here we have a certain, it is type directory. Of course, you have different types here that you can select. and then we are ready to go on the next. And here is where we are going to enter the actual code of the program that I showed you before. Okay, so let me, I have it here already. Let me go and take it from here. So this is our program. I put it here. Okay, so the actual code has been entered, and now we need the requirements, the different requirements needed for the particular program, and we copy them and we enter them here. Okay, our function is created successfully, and now we return back on the workflow view. And so we already have our program. Okay, so we are going to have it to search it in the list of the functions. Object detection on images. This is the one. So we drag and drop it. Okay, so you can see here our function is here, but we only have the function. Okay, we need to understand a little bit how it everything works within Ryax. So functions are certain data transformations. Okay, so we need to create the flow between different functions that are going to express the logic of our whole application. So let's say for the sake of simplicity, I'm going to take a certain form. So I have the selection of different functions here, and I select and I drag them in the editor. So I'm going to take a form, which is a certain gateway that is going to allow us to let's say, submit a video. Okay. Then I'm going to take this function here, which is going to allow me to cut a video into frames so that it can be fed to the object detection program function that I created before. This is the other one. And finally, let's store it. We are going to have as output we're going to have as output the different tagged images. And now what we want here is actually, this is not the one I wanted. This is the one I wanted. We are going to, based on the tagged images that we have, we are going to build a video and store the new video somewhere either centralized or in the cloud, etc. Okay, so let's try to see how things work here. So we saw before that we have created this function. Now we need to create the flow between the different functions. So how data are going to flow from one on another. So we said the first function is going to submit the video. The second one, so we send this data on the second function. The second function is going to cut the video into frames. It's going to feed it on the specific program I showed you before that we just created. And finally, we are going to send the data once the tagged images are done, once the images are tagged, we are going to feed them to our last function, which is going to build a certain video. Now, the only thing here that we need to do is to parameterize our function. So based on the different inputs and outputs that we have, it allows us to select the right choices. I'm going to go fast here so that, okay, here we have a certain model name. I'm going to copy the model name from here that I have it somewhere. Well, okay, I have a certain model name that we are going to use. And then finally here, so this is a simple parameterization of our functions. that is going to help on the way data are going to pass from one function to another. Here again, we select reference. So from the tagged images directory of the object detection, so you have the choice to select where you can. And now here I'm going to enter I think I have it somewhere here. Yes, I have it here. Okay, so I'll go back. Yeah, okay. Okay, so we go back, we do this, we save, and now all the parameters are set. So now what we can do is we can deploy our workflow and go back. And now, for the sake of simplicity, I'm going to stop this and I'm going to start this. It's the same thing. It's going to be faster for us. Okay. Now, I show you how we create a workflow, and I show you how we connect the different data transformations within the workflow. Now, the important thing here to remember is that a workflow is a group of functions where the different data transformations take place. And what we see here is the data flowing from one function to another. Okay, we could have this whole program be made as one function. This could be possible, but cutting it down into multiple functions has a lot of advantages. I will try not to go technical here, but the important thing to remember is that different functions can scale independently. So, for example, the TF detection, which is actually the function which takes a lot of, which may need a lot of heavy processing, can be placed on a specific GPU, while the others are assigned on different type of resources. So one side is the scaling of the different functions, and the other thing is that it allows us to evolve the workflow in a much dynamic, more flexible way. Okay, and we are going to see how after that. Okay, so let's see our workflow is now deployed. So we can go here and we can go on the form that I mentioned before. We are going to actually do a certain execution of the workflow. All the internals are now set in order to receive data. Okay, so what I do here is I choose a file, a certain movie, I submit, and I go back and I check on the execution. So I see that there is actually a new execution being done right now. So while this is executing, let's go on the infrastructure and let's check a little bit the monitoring of our resources. So as I said, the important thing here is that the program is executed on computing resources. In this particular case, these resources are within our organization, but it can be in the cloud, it can be at the edge, wherever Ryax can be installed. We can see here already that the CPU utilization goes higher, the network utilization goes higher. This is related to the fact that we are actually sending the video, and there is some CPU power needed in order to execute the different functions, the different data transformations that take place. Okay, let's go back. Let's go on our execution. Okay, so our execution is done. And here what you can see is that we can see the different functions that we mentioned before with their debugging and their results their execution. Okay, so here is some simple debugging, and if we go here on the right video, which is the function that we used to build the video from the tagged frames, and finally store it on S3, on the object storage of Amazon. And we are going to have this specific link that we can go and download. Okay, so it's downloading here, but I think I have it already. Yeah, it's not that. Okay, so let me show you it from here. Okay, it's downloaded here, so we can see VLC. It's probably, yeah. So here you have the different cars that they pass. So as you realized, it was cut in frames. Every frame was passed through the data transformation of the object detection, and then we rebuilt the whole video into this one. Yeah. So all this was done by this workflow that I just showed you. Okay. And this was a specific execution. Okay, so the workflow is there, is waiting for input for a trigger. The trigger was the actual form that we submitted here, and once this was triggered, the whole workflow was executed. Okay, and it's still waiting for other inputs. Of course, this can be in the context of the project of air quality. It can be triggered through, let's say, a threshold that is bypassed, or a different kind of scenarios can be done here. Now, let's go on a little bit more complex workflow. And what I'm going to do here is I'm going to duplicate this workflow here, and I'm going to name it blaring after object detection on videos. Okay, so our workflow is created successfully, and what I'm going to do here is I'm going to evolve this duplicated workflow, and I'm going to, you see here that it's in off state, so I'm going to use another function that is going to do the blaring, okay? And as a matter of fact, I'm going to duplicate this function as well, so that I can store the video once it's blurred, and the video before it's blurred. Okay, so I'm going to connect these, and I'm going to parameterize here as I did before. So I'm not going to show you actually the code of the blaring is simple. I have it here. You have as input images, and as output the blurred images. Okay, so in the specific case here, we are taking the tagged images from the TensorFlow detection, and we blur those images, and then finally we are going to construct again a new video. Okay, so let me go here and select the tagged image. So you see that once the functions are created, that I'm not going to show you how I created the blurring function, because it will take time. But once this is created, this operation of constructing a workflow can be done by an operator. You do not need to be a confirmed data scientist to do that. You can just select and drag and drop functions from the store and do your workflow and your program directly. Okay, so this is the right video here, and then so you can follow the flow here. Once the images are tagged, we store a video with the tagged images. Okay, and and also through the blurring, the function blurring, we can also go and store this new video. So let's go back here. I'm going to stop this workflow to not consume resources, and I'm going to go here. Yes, okay. So here, what I've done is I have allowed the storage to be done on S3 on Amazon for the video that is blurred, and I have allowed the storage of the video that is not blurred to be done locally. So in that case, we are going to respect the privacy. We are going to pay attention on the privacy by providing images that are completely anonymized, let's say, completely blurred, where we cannot see faces or numbers of cars, etc. Okay, so let's go and run this workflow. And so this is going to be deploying again. We can see the infrastructure here. Yeah, this is the previous peak that we had while we executed the workflow. So here we go back, it is deployed. And what we can do here is let's use another video where we can see clearly, for example, we're going to use this one. I submitted. Okay. Let me see. So if I show you the video here. Okay, so this is the video where we can see clearly the image, the number of the car, and then once the execution is done here, we can see that we have stored on our link here. Okay, so we can go. Yes, if I go back here, yeah, you can see here that it is tagged and also blurred, so we cannot see the number of the car. Okay, so this is what we store in upon S3, and the other one is what we store on locally, so that in case that it is needed to treat it further. Okay, so this is what I want to show you related to the workflow. So let me continue. Let me go back to the slides. I hope that the information that we are getting are not too many. I hope that I'm not bombarding you with too many new stuff. So now, considering again that our object detection is developed, okay, we saw how we can go in production, but how about going into production optimally in a hybrid edge cloud infrastructure? For example, we saw before in the schema of the project that we're going to have a lot of buses that are going to circulate in the city. And we need to do data analytics on all of them, because all of them are going to have sensors. They're going to have processing power dealing with those sensors, so that they're going to send data on the different layers of the computing resources that we have. So how do we deal with all this? First of all, it's, as we said, it is AI based. So we need the models to be executed, but some parts of these executions need specific computational resources. For example, if you want to execute, you may need a GPU, whereas for the inference, it may not be needed. Another thing is, we mentioned that something that we are using computing power within the buses. So in case of submitting all the time all the data, we may execute some parts of the data analytics within the bus in order to minimize the data transfers. We also need, as I mentioned before, to preserve data privacy, okay, to preserve the privacy of the citizens and not send unblurred images directly on the cloud. Another thing is that we may need to replicate or split our workflows or our functions on multiple levels of the hybrid edge cloud infrastructure. And this is going to facilitate our deployment and control. It's going to enable optimal execution upon the whole infrastructure, and it's going to minimize cost and also energy consumption. So to deal with all those challenges, you need a tool that will allow you to actually perform certain mechanisms related to this hybrid edge cloud environment that we are dealing with here. So we're going to go in a second part of the demo where we are going to introduce some notions that we have in Ryax, the notions of labels and clusters to control the hybrid infrastructure. We are going to use properties of functions with the labels in order to assign these functions on specific clusters. And we are going to see how different properties can help us in either dedicating function on specific cluster or specific resource, or replicating the functions across multiple layers. Okay. So let's see first of all the labels. Okay, so labels are a certain notion that we use within Ryax that allows us to intuitively label, let's say, certain resources so that we know what type of execution can be done there. So a label can be created simply. For example, we can create a label named 32 gig of memory, where it will be explained as a node featuring 32 gigabyte of memory. Okay, so we create it here, and once it is created, we can have it here. So let's say that we have created our different labels here, and we can go into the clusters, which is actually our real infrastructures, our real computing resources, and we can assign labels upon those clusters. Okay, so for example, if we go here, we can assign, let's say, you can see here the label that was created before, edge cluster bus and edge cluster. Okay, so I do a save. So in my case here, I've declared, for example, that there is a cloud cluster where we can have actually the label of the cloud cluster, and then another cloud cluster where we have GPUs, or the different edge clusters, they have the label of their specific edge cluster number, but also the common edge cluster label for all of them. Okay, now let's see how we can use this. Let's go in our initial workflow, and let's see a little bit this functionality that I mentioned before of the function properties. Okay, so we can go here and say our workflow is going to be executed on edge cluster 1. Okay, so I'm going to put for one cluster mode here, and I'm going to assign every functions that we have here on this edge cluster 1. Yes, I'm going to save. So by doing this, this labeling of its function is going to be inherited by the whole workflow at the end. Okay, so I'm going to do this for this again and save. Okay, so if I go here, I see that for one, all these functions do have the label edge cluster bus 1. Okay, so we direct this workflow to be executed on the first bus that we have enumerated within our infrastructure. But what about if we want to replicate this whole workflow on all the buses, which is what we would really want to do? I mean, we're not going to have the same workflow to be created again and again for each bus. We're going to have one workflow, and we want to have it replicated on all the buses. So we are going to come here and use the other label. You remember that we created the label that is regrouping all the edge clusters. And what we are going to do here is we are going to do for each cluster. Okay, so in this, for each cluster that we have here, we are going to have this specific function to be executed. Okay, so we have the specific label, and we have this mode of operation where we have for each cluster. So this will allow us to group all the clusters at the edge with one label, and for each of them execute these functions. So this the whole workflow is going to be replicated in all the different edge clusters and all the different buses. Okay. Now, another thing that is interesting here to see is that I mentioned before that each function can be scaled independently. Okay, so in this particular case, we can assign a certain function that needs perhaps more computing resources in a specific domain where we have a GPU. So in that case, this part of the workflow is going to be executed on a specific computational resource that has more processing power in order to be executed faster. But of course, we pay more if we are using the cloud, we pay more. So in that case, you don't want to execute all the functions in the same type of resources. So in that case, we're going to use the cloud cluster, the simple cloud cluster here, and the same label for the other functions. So we saw two different scenarios where the first case, we actually replicated, replicated the workflow on different machines, on different edge clusters. And here we show a scenario where a certain function of the workflow is actually executed on a specific computational resource. Okay. Now, I'm not going to enter into the deployment of those workflows because we do not have enough time. Let me continue on the slides. The important thing here is that I show you one, or I show you actually two different workflows that have been used in the context of this air quality project. But these are only an example at this stage. There are multiple workflows that need automation, and there are multiple workflows so that the whole environment, the whole context of the air quality project can function properly. And here I mentioned some of them. I'm not going to go through all of them, but for example, you can see things such as, for example, in the fog layer workflows, you periodically need to access the directory where measurement data are gathered, clean the data using custom data manipulation techniques, and store them within a database. Upon request, you may extract data related to a selected region, upload them to a selected HPC platform or cloud infrastructure, and then launch a specific simulation using those data and collect the results. Okay. These are things that need to be explained, need to be expressed within the project of air quality. Now, an interesting part here is the workflows that are cross-layer. So we have the context of edge situations where data are collected on drones, they are transferred to the fog layer, and then they are forwarded directly to trigger multiple simulations, etc. Okay, so to wrap up a little bit, we saw how we can go from the prototype state, from the proof of concept to the prototype, and then finally to production by using Ryax platform. And we have seen how we can automate workflows, how we can observe the different resources and functions being executed, and how we can evolve our programs, which are all regrouped as the industrialization of our data science. Okay, so this is what I've got for today. We have different links here that you can follow for more information. You can also contact us for if you have specific questions, and I can answer some questions if there are.
Yes. So if you want to ask your questions, we didn't have any text questions in the chat, but if you will, you can unmute yourself and just ask your question orally if you need it, or just write it in the chat as you wish. We can answer in French, Greek, or English. So feel free, if you have a question, you can unmute yourself. So in the meantime, yes, Yiannis showed you the different links that we had on the left, so you can get to know a bit more about the air quality project in Rennes by going on the acmo.irisa.fr link on the left. Of course, if you need anything on our side, technically, on the value proposition, or any more detail on the Ryax platform and services, feel free to contact us. You have our emails also written on the left. And as you may know for some of you, we also have a demo platform, so you can also get a grasp of what Ryax is doing by navigating the different screens that Yiannis showed you earlier. You can also create your own workflows. This is a non-functional demo platform that we offer access to, but you can start trying Ryax this way. It's a free sign-up access that you can also use with the specific links mentioned on the right. And we offer also a set of tutorials so that you can start also seeing all documentation on how to use the Ryax platform, how to create workflow. Basically, it just takes back what Yiannis just told you in much more detail. So you can sign up to your access for the demo platform and also read our tutorials. We will also host future webinars. We will give you the program a bit later on. If you have any idea, any specific interest for future topics for webinars, also feel free to ask us either in the chat, or if you unmute yourself, or just ask us via email or LinkedIn, any kind of way. We'd be happy to take your ideas if you want to see any topic covered in the future. Thank you very much for taking part in this first webinar, and we wish you a very nice day. Bye-bye.
Thank you very much. Bye.